Okay, so now we're looking at 41, which is inverse trigonometry, continuing with this recent theme, but now we're looking particularly at integration. And you might be wondering, well, didn't we need to do derivatives? Well, we did do that at the end of AB 40. It kind of did derivatives there. So let's look at integration with inverse trigonometry here. So first, just a couple of things, and this is kind of based on what were we looking at? And it came from this first one. If we were doing sine of inverse of u, we were talking about taking the derivative of that, we would get, and this is where we got, what was this? 1 over square root 1 minus x, or I shouldn't say x, it's really u. U squared times du dx. More generally, it's looking at this. What if it's sine inverse of u over a, or where this a right here, what if that's not 1? Well, and there are other ways that you can kind of work around that, but in general, it's going to be involved in this arc sine measure. Similarly for tan, we'll have this one. Now, the one that we're really not thinking about a whole lot, it does show up, but not nearly as much as these, would be the one where we have du over u squared minus a squared, like that. And how do we deal with that? And that's just another one. But these two are the most common that we will see, and we're going to come back to this quite a bit. So let's just look at some examples. Really, you're just trying to match up how it would fit in the original formula. Okay, so 1 minus x squared. That's almost too easy. It's ridiculous. We're looking at a equals 1, u equals x. So u over a is just going to be x over 1. So this equals sine inverse of x over 1. That was too easy. That was way easy. This next one, very similar, but keep in mind that this 4 is really 2 squared, and then this is just x, of course, squared. So really, we see a equals 2 and u equals x. So now when we're looking at the second one, it would become sine inverse of x over 2 plus c. Forgot the plus c for the first one. It's probably yelling at the screen. But there we go. For the third one, again, very simple. U equals x, and a in this case equals 1. So it's just 1 over a, which is 1 over 1, times tangent inverse of u over a, and that'd be x over 1, plus c. And that's it. That's really what we're looking at. Now there are other ways to kind of derive that, from kind of like a long way, and we're going to look at that, I think, here in a second, using a lot of the same right triangle trigonometry that we have been looking at. Go through some slightly more advanced versions of stuff here. So when I look at number 4 here, I can see some things that aren't exactly obvious, and this one does require inverse trig, where some other ones might not, and that's where it gets kind of funky. Like, how do I deal with that necessarily? Okay, so for this one, we look at this and we'd want to say, if I were to try to do this like a u substitution, I would say u equals 5 minus 2x squared. And then I'd just have the integral, and this would be u to the negative 1/2, and then I got the dx. Okay, so I got to take care of that dx. We do du dx is really negative 4x, and then I'd start trying to move stuff around. But the problem is there's no x. It's not there, and it needed to be there. So when you're stuck with that, then you should start considering some trig substitution. So I see that this is really kind of like du over a squared minus u squared, all inside a radical. So if I wanted to do that, that would mean that a is in fact square root of 5, because square root of 5, if a squared equals 5, then a is square root of 5. Similarly, if u squared is 2 times x squared, when I square root both sides of that, I'm going to get u equals square root of 2 times x. Okay, so that's what we have so far. And it's going to be the sine inverse one because we got this subtraction inside a radical. So I know that this is going to be sine inverse of u over a and then plus c. Well, u in this case is square root 2 times x. And a is square root 5. So there we go. Now this next one, why is it different? Well, notice it has the x. So there's, a lot of things that I could kind of try to work my way around, but in general, actually, this is much easier with a general, just kind of straightforward u substitution. So if u equals what are we looking for? If u equals 5 minus 2x squared. So now I'm going to do this one like I tried to do the last one, but last time I ran into a dead end. Then I would have, an x dx here, and I got square root of u on the bottom. So if I were to simplify that just a little bit more, I'd have u to the negative 1/2 times x dx. So now I got to get rid of that x and dx piece, these over here. Well, if I take the derivative, du dx, of that equation substitution that I started with, it's going to be negative 4x, because the 5 goes to 0, and then we got negative 2, drop the power, and all that kind of stuff. Now that I look at this, I can do some algebra, and I'd have negative 1/4 du equals x times dx. If I multiply the dx to both sides, divide negative 4 to both sides, now I have an x dx like I had here that I need to swap out. So I'm going to take that out and replace it with this, the negative 1/4 du. So now for the final piece here, we still have u to the 1/2. We're going to have a negative 1/4 and a du. That negative 1/4 is really just a constant. So that just tags along. No big deal. Then what's u to the 1/2? What's the antiderivative of that? Well, that's going to be u to the 3/2. Oh, that's negative 1/2. Pardon me, so it's not u to the 3/2. In reality, that's, what would that be? That's u to the positive 1/2 over 1/2. Now, if it's divided by 1/2, plus c, of course, that really means it's going to be times 2 over 1. Then we got u to the 1/2, and u in this case is 5 minus 2x squared. Then these two parts simplify. We'd have negative 1 over 2 times square root 5 minus 2x squared plus c. All right. Okay, so what's going on with this next one? And here's something that a lot of people, they say, well, no, it's a tangent trig inverse. Well, if it were tangent, this a squared plus u squared. The problem is that if du was e to the x dx, then u would be e to the 2x, or e to the x squared. Or u squared, I should say. U squared would be e to the x squared. And so the problem there is that it's not. It's not that. And so this down here, that's not squared, it's just u, or a du. So it doesn't fit that pattern. However, it does fit another pattern that we have studied recently. That other pattern is natural log, where we're looking for du over u, or 1 over u times du. So let's say that I did a u substitution where I have 9 plus e to the x, then du dx is going to be, well, the 9 goes to 0, and the derivative of e to the x is just e to the x. So I multiply by dx on both sides, and I'd get du equals e to the x dx. Excellent. Okay, so now when I rewrite this, I have the 1 over u, because this bottom part down here is u. And the du is the e to the x dx, that's this other part up there. So what's the antiderivative of that? It's just natural log of u plus c. And in this case, u is 9 plus e to the x. So it's natural log of 9 plus e to the x plus c. There we go. That's our answer. So sometimes you're going to use tricks, sometimes you're not. And it's probably the most confusing thing is going to be, when do I do it, when do I don't? Well, here's your clues. And you got to kind of, there's a couple ways you could think about it, but probably the most straightforward is need to memorize this. So this needs to be in your memory. Let's go through a couple more examples. So here, we got lots of stuff going on. And you're going to say, my goodness, why does it... Well, when I look at this, I see 4 minus x squared. And if I were to say u, or let's call it w. Let's do a w substitution. If w equals 4 minus x squared, and then I say, well, what's dw? Because that would give me x plus 2 dx over square root of w. But I got to get these top terms into terms of w. Well, a couple of things that I could do. I see that, really, honestly, that's kind of tough to do it that way. Well, let's see what we would get. If I were to do dw dx, I would have negative 2x. And that's not really what's up here. It's an x plus 2. So I'm going to try and split this. I'm going to split it to two different things. I'm going to have x over 4 minus x squared, dx of course, plus 2 over 4 minus x squared. Just like that, dx. Now this first one, I would continue with what I was doing here. dw dx is negative 2x. So if I were to get rid of that negative 2, then I'd have negative 1/2 dw equals x dx. How does that help me? Well, the x dx matches there. My w matches here. And then I just have a negative 1/2 extra. So this is going to become the integral of negative 1/2. Then we have a du, or dw, pardon me, dw. And then it's u to the negative 1/2. How did I get negative 1/2? Well, it's a radical, that's 1/2. It's in the denominator, that's negative. So, and this is w to the negative 1/2. Alright, so, and I haven't even dealt with the second half of this yet. I still got this whole other piece over here. 2 over 4 minus x squared, and that should be in a radical. Should have written that in a radical there. Okay, so antiderivative of the first part is going to be negative 1/2. We got w to the negative 1/2 becomes just w to the 1/2 over 1/2. And if we were to simplify that all the way, this 1/2 and this 1/2 here would actually kind of cancel each other out. And that's just going to be negative square root of w, which is really negative square root of 4 minus x squared. There we go. So that's that piece. Now the second piece, actually, I look at it kind of like this. I see it as a 2, that's a constant, but then I really have the 1 over, or what do we have here? No, that 2 is going to help. Yes, it is. Because if I say a equals 2, then this is kind of a squared. And if u equals x squared, then du is going to be, well, what is d? Oh no, I shouldn't say that. U is an x squared. U is x. Du is just dx. So I have this one, or this 2 here that's extra. That 2 is going to be a constant. So in reality, this is like 2 du over square root a squared minus u squared. So altogether, we got the first term, which is negative square root 4 minus x squared, plus the second term, which is an inverse sine. So that's going to be, and we have the 2 as a constant there, so that constant 2 sticks out front. Then we have sine inverse of, well, what would we have for that? A over u? U over a. So u over a is x over 2 plus c. Okay, so you guys in the 8 and 9 are probably going to take up quite a bit of space here. So I'm going to do ourselves a favor. I'm going to move it on to the next slide, and we're just going to use all this empty space for 8. Okay, so there's 9. It's right now. Let's cover up what's over here. There we go. Now we can write on top of it. Okay, so I look at this, and again, this is going to be helpful if I split it up into 2. I'll let you imagine which 2 they are. How do I know that? How do I know that that's going to happen? Well, because x squared plus 4, if I were to look at this other top piece as kind of a derivative of that, it'd be nice if this was just x, but the x plus 2 thing kind of throws me off. It doesn't really help me, per se. You know, but let's take a look at this. Let's say we look at this as x over x squared plus 4 plus 2 over x squared plus 4 dx, of course, for both of these. If that's the case, you know, and this is the same, some people don't realize this, even though it's pretty straightforward. For the second one, this is going to be our tangent one, because we have a u squared and an a squared. You might be thinking, but wait, no, this says a squared plus u squared. But that's really the same thing either way, because it's like 2 plus 3, 3 plus 2. Addition has commutative property on it, which means that it doesn't matter which one comes first if we are adding. For the first one, though, it's more like a u and a du kind of format. So let's again use w's, just to keep that separate from a and u and the other substitutions there. So if we were to say w equals x squared plus 4, then dw dx is going to be 2x. Now let's start matching our pieces together. W is x squared plus 4, that's down here. So we're going to have u in the denominator. In the numerator, we're looking for the dx piece, so we multiply both sides by dx here. And we're going to divide by 2, so it's really 1/2 on the other side. So 1/2 dw gives us x dx, which is here. So I'm going to have my dw, but I have this 1/2 there as well. So it's really the antiderivative of 1/2, 1 over u dw, or 1 over w, my goodness. 1 over w. Too many u's and w's. So what would this come out to be? Just for the first half, we'd have 1/2 natural log of the absolute value of w, which in this case is x squared plus 4. Now for the second half, we're looking at more of a trig substitution here. The u is going to be just x. That was easy. The a in this case is 2, because 2 squared is 4. And notice that we're going to have this leftover 2 here as well. So we're really looking at 2 times the, oh, and we should say du is dx. 2 times du over a squared plus u squared. So that constant, that just tags along. So that's going to be a 2. And we're going to have 1 over a. So what's 1 over a? That's 1 over 2 in this case. And that's kind of interesting. 2 and 1/2. Those guys cancel each other out. then we're going to have tan inverse of u over a, which in this case is x over 2 plus c. So lots of work there, lots and lots and lots of work. So the finale, number 9, here we go, finishing with number 9. So I look at this one, and what do I see? Here's something that I first noticed. I see that this degree is smaller than this degree, and when the denominator is a smaller number than the top piece, then we can actually do some division. So I'm going to divide x squared plus 1 into x cubed. Now keep in mind that this really has plus 0x squared plus 0x plus 1, or plus 0. So we got to work our way across this. So x squared goes into x cubed x times. And then if I were to multiply that back, I would get x times x squared is x cubed. And x times 1 is x, which would go here. And if I were to subtract these two things, I'd have a 0 here. And this is really a 1x, so we're going to have minus 1x. You might be thinking, well, can't I divide any more? No, I can't, because x squared doesn't go into x to the first. So we're done. Now we're into pieces that are really too small. So what does that mean? That means that this can really be written as x, my first piece, plus the remainder, which in this case is negative 1x over x squared plus 1 dx. Wow, is that it? Kind of. That's a lot of setup, but it's really going to help us. And check this out. So if I have the first term here, I can just take the antiderivative of that. No big deal. It's going to become x squared over 2. For the second half, this is really a u and du kind of relationship that's going to deal with natural logs. So if I say u equals x squared plus 1, then let's go into a different color here. How about purple? Du is going to be 2x. du dx is 2x. I have a negative 1x. That negative 1 is going to be a constant I don't deal with, but the x and the dx, I can get those out. So I'd simplify this to 1/2 du is x dx. At this point, I see x dx. I can take this out and replace it with 1/2 du. Alright, so that gives me, we got the x squared over 2. That part's done. But this second part is going to be the integral. And we have 1/2. We got a du and a 1 over u. Oh, and there's a negative 1 in there, so we need a negative there as well. This is 1 over u. 1 over u. Okay, so now what would that simplify to? We'd have negative 1/2 is a constant. 1 over u du becomes natural log of the absolute value of u. And u in this case is really x squared plus 1, which is always going to be positive, so we don't really need the absolute value. And then here in the beginning, we got x squared over 2. So there we go. Lots and lots of crazy work. Oh my goodness. But you'll probably be happy to know that this is about as complex as integration gets. This is the top level of integration. And a lot of it starts with the idea that you actually remember these key formats. So keep those on flashcards, keep working with them. Remember those. It's the same way that you should remember things like e to the u du. You should remember 1 over u du. All these kind of things. Those are all formats that you need to be familiar with in your head, and you need to practice recognizing. Okay, so that's it for this video. We will see you in the next one.